Hello guys, welcome to the another enlightening session on cloud computing, the chapter 2 part 1. So this is the chapter use of the platforms in cloud computing, and the part 1 is the virtualization in the cloud computing, its concepts and types. So in this video we will delve into the fascinating world of the virtualization in the cloud computing, the cornerstone of cloud efficiency. We will explore how abstraction and virtualization simplify the resource management, uncover the various virtualization types, and decode the mobility pattern like the P2V, V2V. You will also learn about load balancing's role in the cloud performance, with Google Cloud as a primary example. Finally, we will dive into the virtualization techniques or technologies like the Hypervisor, the VMware, vSphere, which power the modern cloud infrastructure. So let's begin this insightful journey. At first, the abstraction and the virtualization concept. So abstraction and virtualization are the foundational to the cloud computing, enabling the efficient management and the scalability of the resources. Abstraction hides the complexity of the underlying hardware, presenting the simplified resource view to the users. Means you can say the front end. This ensures the seamless interaction with the virtualized environment without needing the in-depth hardware knowledge. Virtualization, on the other hand, creates the multiple virtual resources like the server, storage, or the networks from a single physical system. It allows the hardware to be shared among the multiple users or tasks, optimizing the resource utilization. By decoupling the physical infrastructure from the applications, virtualization ensures the flexibility and the portability. It is crucial also for the cloud scalability. These principles empower the cloud platforms to dynamically allocate the resources based on demand, supporting the multi tenancy and the reducing the hardware dependency. So now the virtualization types. Virtualization manifests the in various forms to cater to diverse need, like the access virtualization. It facilitates the remote access to the system, enabling the users to interact with resources anywhere in the world. Application virtualization isolates software from the operating system, ensuring compatibility across the environment. CPU virtualization allows multiple virtual CPUs to run on a single physical processor, dividing the computational power among the virtual machines also. Lastly, the storage virtualization. It aggregates multiple storage devices into a unified virtual pool, simplifying the data management. Together, these types provide robust solution for optimized resource uses and scalability, making them integral to cloud services, flexibility and efficiency. So now the mobility pattern, P2V, V2V, etc. So mobility pattern define how the workload transition across the computing environment. It is vital for also cloud flexibility. Means P2V, like the physical to virtual. It converts the physical servers into a virtual machines, optimizing the legacy system use. V2V, like the virtual to virtual. It allows the migration between the virtual environment, supporting the disaster recovery or load balancing also. P2P, or the physical to physical. It involves direct data transfer between the physical systems. It ensures or it ensuring the minimal downtime. Other patterns like the D2C, device to cloud, C2D, cloud to device, enhance the mobility between the edge devices and the cloud platforms, fostering the IoT integration also. These patterns ensure the workload portability, critical for the dynamic resource management and the business continuity in the cloud environment. So now the load balancing and the virtualization. Load balancing ensures the optimal resource utilization by distributing the workload across the servers. Basic load balancing prevents the work or the overloading a single server. maintaining the system's performance also. It utilizes the network resources like the bandwidth, routing mechanism to spread the traffic evenly. Advanced load balancing employs the application delivery controllers ADC and the application delivery network for intelligent traffic management. So these systems analyze the traffic pattern and allocate the resources dynamically, ensuring the high availability and the scalability. Google Cloud exemplifies the effective load balancing with its global infrastructure, leveraging the real-time metrics and advanced algorithm to maintain the service reliability even during peak usage periods also. So now the Google Cloud. So Google Cloud showcases the power of the virtualization and the load balancing in the cloud computing. Its platform uses cutting-edge virtualization technologies to manage the resources efficiently and ensures the high performance through the intelligent load balancing. Google's global infrastructure minimizes the latency and supports the scalability, enabling the services to handle the varying workloads seamlessly. Features like the real-time monitoring and automated scaling adapt to users' demand, maintaining the consistent service quality. Google Cloud's integration of tools like the Kubernetes further demonstrate its advanced resource orchestration. This example highlights how innovative technologies drive the reliability and the flexibility in the modern cloud platforms and also setting industry standard. So now the virtualization technologies. So the virtualization technologies underpin the cloud computing's efficiency. Hypervisors manage the virtual machines, allowing the multiple operating systems to run concurrently on a single host. They come in two types: bare metal type 1 and hosted type 2. VMware vSphere streamlines the virtualization with features like the automated management and the scalability. Machine imaging simplifies the VM creation, enabling the easy deployment and backup. Standards like the Open Virtualization Format OVF ensure the interoperability between the virtual environment, promoting the compatibility across the platforms. Together, these technologies enhance the flexibility, security, and manageability of the virtualized system, driving the innovation of the cloud based infrastructure also. So, today we unveil the essentials of the virtualization in the cloud computing from its foundational concept to its real world applications. Understanding these elements is crucial for grasping how cloud systems deliver the flexibility and the scalability. We hope this session has given you a clear perspective on the virtualization, its role in the cloud ecosystem. So in our next video, we will further explore how platforms like the PaaS revolutionize the application development. Stay tuned and keep learning. So we will meet again in the part 2 of the chapter 2. Okay.